All right, chapter 1.3, segments. How can I find and compare lengths of segments? So there's a few definitions we should know before you get started. This won't be too bad. Midpoint is exactly what it sounds. It is the point in the middle. So definition. The point exactly in the middle of a segment. So for example, if I had point A and B here on the endpoints of that segment, and I wanted the point right in the middle, it would be exactly in the middle. I'm going to call that M for midpoint. Now, one thing about geometry, again, we never make assumptions. So just because M looks like just because M looks like it is in the middle doesn't necessarily mean it is. I mean, the way I drew it, it kind of looks like it might be a little closer to A than to B. But to show it's exactly in the middle, we'll put tick marks. Because if those distances are the same, right, if it's the same distance from A to M as it is from B to M, then M has to be exactly in the middle. So don't forget those tick marks for congruence. If those tick marks are there, it means they are equal, even if it doesn't appear to be. Even if you do a horrible sketch like, say, X, Y, and let's say Z is right here and doesn't look at all in the middle. But if I put these tick marks here, one there and one there, then I'm saying even if my drawing is horrible like that one, Z is the midpoint, it's in the middle. So midpoint, the point exactly in the middle of a segment. A couple other definitions. Bisect, we're not going to talk about these a lot today, but bisect just means cut in two, or more especially cut exactly forgot my C. Exactly in half. So for instance, maybe I've got this segment AB and I want to bisect it with a line, then that line would go exactly right through the midpoint of AB. Again, if you want to show it's exactly halfway, don't forget those tick marks to kind of show that that line is cutting it exactly in half. So if I label this line M, then line M is bisecting segment AB. That line M would be what's known as a segment bisector. Segment bisector is the thing that bisects a segment. In this case, that thing is line M. So I could say line M is the segment bisector of AB. Because segment bisector is the thing that cuts it in half. Line M is what's cutting AB in half. All right, we're not going to use those two nearly as much as midpoint, but a lot of this chapter is going to be focused on finding lengths. It shouldn't be too hard. So we have a number line, and I want the length of ST. So ST starts at S and goes to T. Well, you could just count it, right? It looks like these are counting by twos. So 2, 4, 6, 8, 10, 12. I could say, hey, that's a length of 12. But it actually tends to be easier just to subtract. If I do 8 minus negative 4, you guys remember minusing a negative? That's like adding a positive. So that's like 8 plus 4. That's 12. So if you know the positions of your points, like S is at that spot -4 and T is at spot 8, if you just subtract those, 8 minus -4, that gives you 12, because the way you can find a distance is by subtracting the bigger one from the smaller one, right? So that's one way we could do it. Or if you want to just count, you can count. It doesn't matter. However you want to find the length of that. Oops. Went too far. All right. Let's do a couple others. If you want to pause the video and try these two on your own, go for it. Otherwise, I'll do it. I'll do it one each way. I'll do one counting and one with the subtracting. UV, I'm going to do that by counting. Here's U, here's V. Again, these are counting by 2s, so that's 2, 4. That's a length of 4. SV, that would be starting from S and going all the way to V. I don't want to count there. That's a lot of counting. So I'm going to do that subtraction trick. I'm going to start with the value at V, which is 14. Oops. And I'm going to subtract the value at S, which is -4, which gives me a total length of 18. If you're ever not sure if you did it right, you can always count it. That's the 2, 4, 6, 8, 10, 12, 14, 16, 18. Yeah, that's a distance of 18. But that subtraction trick's going to work for you every time. All right, not a problem. Problem 2, are AC and BD congruent? So you got to remember what that word congruent means. That word means equal. So in other words, are they the same length? Well, let's find out. So from A to B, B is like that halfway point. That looks like it's on 3. So let's find out how long that is. I'm going to use that subtraction trick again. AB is at the 3 marker minus the one behind it, -2. 3 minus -2, that's like 3 plus 2 again. That's 5. So AB has a length of 5. Then it wants to see if BD is the same length. So let's take a look at BD. BD, let's change color here. BD starts here and goes there. Let's use that subtraction technique again. There's BD is at 10. Minus, that was right between 2 and 4, so that's at 3. 10 minus 3, that's 7. Those are definitely not the same length. So the answer is no. AB is not congruent to BD. If they were congruent, they'd be the same length. All right. Now we get into some algebra. It's been a while since we did algebra, so let's talk about what we know here. At the top for this problem, it says EG is 59. So I know the whole length from E to G. That whole distance is 59. And then it's asking me, what are EF and FG? Well, they've got this X here, and I don't know what X is right now, but I could figure it out because of that first thing they told me. They told me that entire distance is 59. And I know that entire distance is this distance, which is 8x minus 14, plus that distance, which is 4x plus 12. So I know if I add those two distances together, I should get a total distance of 59. So we can use our algebra skills and actually add them. So I'm going to take that 8x minus 14, and I'm going to add the 4x plus 1. So this was the distance of the first one, that was the distance of the second segment, and I know if I combine those together, I get the length of the entire thing, which I found was 59. All right, so now we got to go back to our algebra skills and remember how to do this. On this side, I've got some like terms that can be combined together. There's that 8x, and that 4x. They both have x's, so I can combine them together. 8x's plus 4x's, that's 12x's. I've got a -14 right here, and I've got a +1. Those are like terms, so I can combine them together. -14 plus a +1, well, that's like -14 plus 1. That makes it 1 higher. That makes it a -13. So that's like a -13. All right, -13. I didn't do anything with the right side yet, so that's still 59. And then it's just about getting that x by itself. I want to get x by itself, so I got to get rid of the -13. The opposite of minusing 13 is adding 13. But if I add 13 to the left side, I also have to add 13 to the right side. These 13s go away because adding and subtracting are opposites, right? Adding 13 and subtracting 13 is opposites. That's why I did it. I wanted to make them go away. And I end up with just 12x by itself on the left side. On the right side, I have 59 plus 13. Let's see here, 9 plus 3 is 12. Carry the 1, 5, 6, 7. That's 72. And then I got to get rid of that 12 so I can get x by itself. So I got to remember the opposite of timesing by 12. Right now, this is 12 times x. The opposite of multiplying by 12 is dividing by 12. So to get rid of that 12, I'm going to divide both sides by 12. Again, on the left side, that multiplying and dividing by 12, those 12s are going to go away because multiplying and dividing are opposite operations. And I'll end up with x by itself is whatever 72 divided by 12 is. If you know that in your head, great, it's 6. If you don't, use a calculator. That's just fine. So I found what my x was. One thing with some of these questions is be careful that you go back to the question and read it. Make sure you answered the question. The question asked us what are EF and FG, and I didn't find those yet. I just found that I found that x was 6. So to finish this problem up, let's actually figure out what EF is. I know EF is this distance here. It's 8x minus 14. But now that I know what x is, I can actually figure that out. X was 6. So instead of 8 times x, I've got 8 times 6 minus 14, which you could just plug into a calculator if you like. Or if you want to do it by your head, you can. 8 times 6 is 48 minus 14. 48 minus 14, that's 34. I do not mind if you use calculators, that's just fine. Let's also find FG. FG was right up there, 4x plus 1. But again, now I know what x is. X is 6. So I can plug that 6 in. Instead of 4 times x plus 1, it's 4 times 6 plus 1. 4 times 6 is 24, plus 1 more is 25. So a little bit of math. You got to set up, the biggest part for this is setting the equation up. This one I could set up because I knew adding those two lengths got me 59. So I literally added them to get that 59. All right, let's do at least one more problem. Yep, and then we're done. Same type of problem, a little bit of algebra, but we got to figure out what we know and don't just make assumptions. I'm not going to be adding that this time. This time it says Q is the midpoint of PR, and then it's asking what are PQ, QR, and PR. Well, if Q is the midpoint, I know it's exactly halfway between. And if I know it's exactly halfway between, I know that this left half and that right half are the exact same length. If they're the same length, they're equal. So I know 6x minus 7 has to equal 5x plus 1 because those segments are equal in length. Then you just go back to your algebra skills. For algebra, a problem like this, I've got x's on both sides of the equation, on the left side, on the right side. I don't really like that, so I want to get rid of this 5x here so it's not there because I want them all the x's on the left-hand side of the equation. So I'm going to do a minus 5x because 5x's minus 5x's is 0 x's. Those x's will go away on this right-hand side. And when they go away, all I'll be left with is that 1. On the right-hand side, 6x's minus 5x's, that's just 1x. You can write 1x, or you can just write x, because that's just 1x. I didn't do anything with this minus 7 yet, though, so that's still there. All right, so x minus 7 equals 1. I just need to get rid of that minus 7. Again, we do the opposite. The opposite of minusing 7 is adding 7. If you do it to one side, you have to do it to the other. Those 7's go away. I end up with x by itself is equal to 1 plus 7, which is 8. Again, double check that you're answering the question. This one was asking for PQ, QR, and PR. I found x. Excuse me. But I need to find those just in different distances. So we just do that, PQ. Up here it said PQ was 6x minus 7. But now I know x. X is 8. So instead of writing 6 times x minus 7, we can go 6 times 8 minus 7. You can plug that in your calculator or do it in your head. 6 times 8, let me think, that's 48 minus 7. 48 minus 7, that's 41. I can do that one in my head. There we go. QR, it told me what that was. 5x plus 1. However, I already know what I should get, what the answer should be. I'm going to pause here, see if you can remember. What about Q? Q is a midpoint, right? If the midpoint is, if Q is a midpoint, what do we know has to be true about PQ and QR? That's right. They have to be congruent if Q is a midpoint. They have to be the same. So before I plug anything in, I should know what I'm going to get out. I should get a 41 out for an answer. I'm actually going to work it out though as 5x plus 1 because it's a good way to check if I was right. So let's plug in that 8 because I know x is 8. That'd be 5 times 8 plus 1. 5 times 8 is 40 plus 1 more, 41. They are indeed the same. The last one it asked for me was PR. PR starts at P and goes all the way to R. But if I know this left-hand side is 41 and that right-hand side half is 41, well, 41 plus another 41, that's going to be 82. All right. That is your lesson on segments. Your assignment is section 1.3. It's on page 24 of your textbook. These problems, good luck. As always, feel free to stop by anytime. I would love to help you do this. See you later.